Jai Hind everyone. After discussion of linear and non-linear partial differential equations of first order, we are here to discuss partial differential equations of higher order, this time with constant coefficients. This topic actually includes two parts. First is homogeneous partial differential equations and second one is non-homogeneous partial differential equation. In this lecture video, we will focus on homogeneous partial differential equations. First, we should understand what is linear homogeneous partial differential equation of nth order with constant coefficient. This equation is the general form of linear partial differential equation of nth order with constant coefficient in homogeneous form. It is called homogeneous because all the terms contained here derivatives are of same order. Coefficients are constants itself and nth order represent higher order than 1. So, in continuation to solve such kind of equation, first we should try to understand the general notation that will be used throughout the lecture. Here, del by del x is represented as capital D and del by del y will be represented as capital D dash. In similar manner to that, the topic we have discussed in first year, you must have studied in first year, that was differential equation of nth order with constant coefficient. In those equation, the independent variable was only 1, so their representation was only D. But in this topic, we are in discussion with partial differential equation, so at least two independent variables must be there, and if two independent variables are there, notations will be different. For del by del x, that will be D, and notation for del by del y will be D dash. So such kind of equation can be seen easily when we will study this topic. So now, rules for finding the solutions of such equations are similar to that of differential equation of solution of differential equation of nth order with constant coefficient that you have studied in first year. So the complete solution is the combination of two parts. First is CF and second is PI, that is complementary function and particular integral. Complementary function will be obtained according to the equations, differential equation that is placed on left hand side, and particular integral will be solved for the function that is placed on right hand side. So first we are going to discuss over here only the rules for complementary function. For example, we have taken an equation of form this, where right hand side is placed 0 because we are not going to discuss PI here. So this is the partial differential equation. D represent derivative with respect to x and D dash represent derivative with respect to y. So what we do to solve the CF part of this kind of equation, we actually frame auxiliary equation. I hope all you remember the topic in first year. Similar manner, we will frame the auxiliary equation for this. D will be placed as m here and D dash will be placed as 1 here. Please note what we have to place. D will be placed as m and D dash will be placed as 1. So we will obtain an equation of form this, which contains only m. We will solve this equation. We will solve this, simply factorization we have to do. We will solve this equation. If we are to obtain these two terms as factors or roots, if we obtain these two roots, say m1 and m2, the complementary function can be written as f1 y plus m1x plus f2 y plus m2x. And if the roots are equal, say m, then complementary function is written as f1y plus mx and plus x f2y plus mx. Suppose two equal roots are there, according to that this solution has been written. For example, this equation has been taken to solve complementary function part. Right hand side is placed 0 because pi is not being discussed here. So firstly, as the rule has been discussed, what we will do, we will place d as m and d dash as 1. So this kind of equation we will obtain. A general equation may be quadratic or cubic in form of m. We will simply factorize this equation and obtain roots for this. For example, this question, after solving this equation, we obtain roots as 0, 1 and 3. So the required solution can be written as f1y plus mx means plus 0x, that will give the second part 0. So y, f1y is written over here, plus f2y plus 1 into x, that is written over here, and plus f3y plus 3x. So this is the complete solution for this question, because right hand side is 0 itself and its solution will be decided by complementary function itself. So second example has been taken in this continuation. Solve the equation given as del 2z by del x square minus 4 del 2z by del x del y plus 4 del 2z by del y square is equal to 0. To solve this equation, we have written the equation in this form. Again, to frame auxiliary equation, we will place m in place of d and we will place 1 in place of d dash. This equation will be obtained. Simply factorize this equation and obtain the roots for this equation. When you will obtain roots, see, for example, these two equal roots are obtained over here. So the second rule will be followed over here. Case 2, f1y plus mx means 2x because value of m is 2 over here, plus because we have obtained repeated roots, so we have to place x over here, then f2y plus again mx that is 2x. So this is the solution for this equation. Now we move on to the rules to solve particular integral for such equations. In this continuation, we have followed two general methods over here that will cover even every kind of function that is placed on right hand side. So two general methods are discussed here in this lecture video. First case I am going to discuss. First general method, it can be used when right hand side function is of any form. So we have taken an example over here. For example, d square minus dd dash minus 2d dash square z is equal to right hand side function is written over here. It is a function of y and e to the power x, something like that. So to solve this equation, we have to actually solve first complementary function for this question, and then we will discuss pi for this question. To solve complementary function, again we have to follow the same method. We have to place m in place of d and 1 in place of d dash. We will frame an equation of this kind. After obtaining this equation, we will obtain the factors and finally the roots for the equation. If roots are real and different, we can place our complementary function in this form. Finally, we are going to discuss the rule for pi here actually. So we will write pi in the form this. We have to place our function of d and d dash in this form, 1 upon function of d and d dash, because this is the traditional method to place our pi, particular integral, as we have previously discussed in first year also. And we will place the function that is on right hand side over here. Then in continuation to solve this function, what we will do, we are actually discussing the method in this question itself. So please pay attention everyone. So what we have to do, we have to first see, we have to factorize this equation, because without factors this method cannot be followed over here. So we will factor that equation and place these two factors over here, maybe 2 or maybe 3 factors, whatever number of factors we have, we should place it here. Then we have to place our function here, that is on right hand side. Then we will solve it one by one. We will solve this function with these factors one by one. We can proceed for this firstly as well, or firstly with this as well. It will make no difference at all. So first, in this question, for example, we have solved this function with this factor. What we will do here, the rule, we should try to understand the rule. We are discussing here rule itself, so please pay attention. What we will do, we will place an integration sign over here. Then in the right hand side function, what we have to do, we have place x as it is. We have to place x as it is, and we have to replace y with the term c minus 2x. From where this minus 2 will come? This minus 2 will come from this part. So we have to replace y with c minus 2x kind of term, just to solve our question, because we are going to place this value back to y at last itself. So it will make no difference. It is just to solve the question. So after placing this, what we have to do, we will simply integrate it by parts, or previously learn any kind of method we have used to solve this integration part. We can use by parts, or we can use that u and v kind of integration function part. Those you can recall, you can use it here. So after solving this, simple integration is done over here, actually nothing special. After solving this, we will place this equation c minus 2x back to y, and after placing this, what we have to do, we have to simply solve this equation. Simply plus and minus we have done there over here. After this, lastly, what we have to do, now we have to solve this obtained expression with the another part of factor that was left here. First we have solved the function with this factor. Now this part is remaining actually. So now the solved part will be solved by this factor itself. So again we have to repeat the process, means we have to place x as it is only in this function, and we have to replace y with again c plus x. From where this plus x plus 1 will come, this plus 1 is a part of this. Whatever is written over here, maybe plus or maybe minus, we have to place as it is in this equation. This idea has been come over here actually. So after this, the process is same. We will place an integration, we will replace y with this term, we will place x as it is, and we will obtain the term as it is mentioned in the method. After that, we will use any method to solve integration, maybe by parts or any you have learned till now. And after solving this, don't forget to place this expression back to y. After solving this, we have to place this expression back to y itself, and on last steps solution we will obtain this. This is the PI part of this question. So hence the complete solution can be written as the sum of CF part plus the sum of pi part. Means this is the CF part and this is the pi part. The sum of these two parts is written as the complete solution. So this is the method. In continuation with this, let us solve one more question to understand the method. Here is the question: del 2z over del x square, del 2z by del x del y minus 6 del 2z by del y square is equal to y cos x. As already discussed in the method, that right hand side function can be of any form. So this is y cos x, not any specific form. To solve this, again, what we will do? First, we will focus on CF part. CF part solution follows d to be placed as m, d dash to be placed as 1. We will frame the auxiliary equation, factorize the equation and obtain roots. After obtaining roots, we will place these values of m in the complementary function formula itself. Now, to solve pi part, particular integral, again the same method has been followed over here. What I have told in previous slides, we will factor this equation right over here and this right hand side function will be placed over here. Then one by one we will place this equation to solve one by one with the factors itself. Suppose we are going to solve with this factor first. So what we have to do? We have to place an integration sign. Then we have to replace y with c plus 3x. 3 will be coming from here. Plus 3x into cos x dx. Solve this by parts or any previously solved method of integration. After solving this, we will place c plus 3x back to y. Finally solve it and the obtained solution will be again solved with this another factor part, that is d minus 2d dash. So again, if we are going to solve the equation with this part, we will place an integration, replace y term with y is equal to c minus 2x part, and another existing parts are written as it is because x is not to be replaced by anything. Only we have to replace y with this term c minus 2x. After this, we will solve it generally. General integration we have done here. And finally, we have to place this c minus 2x. After solving, we have to place this c minus 2x as y again, back to y again. This is the final solved pi part. And the complete solution must be written as z is equal to this sum of complementary function part and particular integral part. These two parts will be added to achieve the final answer. This is the one general method that we have used to solve this homogeneous partial differential equation of nth order with constant coefficient. Now, moving further on the second general method. Second general method is basically used for the function of form this. It is actually a linear form. We can see it is a linear kind of form. So this general method is basically implemented on the form of this only. So what is the method actually? We will follow the steps over here. First, we will replace what we have to do in particular integral part actually. We will replace our d with a. This is the solution part of pi. We will replace the d part with a. A will come from here. After recognizing this function, actually this is of linear form. Any function can be written in the place of phi. It may be log, cos, sine, tan, or exponent, or even algebraic function maybe. If we can recognize the linear part, we can compare the our given question with this expression, and we can easily obtain a and b. Then what we have to do, we have to place a in place of d and b in place of d dash. After that we have to place integrations, and we have to replace this linear part with u for some time just to solve our equation. And how many times we have to integrate, actually this depend on the question. This depend on the question actually, because what I am saying is we are solving here homogeneous partial differential equation of nth order. So we can easily recognize the order of partial differential equation, and the order of partial differential equation will decide that how many integration we have to place over here. Means if we are solving a partial differential equation of second order, we have to place integration 2 times over here. If we are solving a partial differential equation of order 3, we have to place 3 times integration, and so on. This is the method actually, and this method fails if we obtain FAB as 0. This method cannot be used, or case of failure will be implemented over here. Case of failure is will be used in similar manner as it was discussed in first year. If it will come in further slide, I will discuss it with you. Okay, now move on to the question. Let us take some problems from this part. We have taken a question, a homogeneous partial differential equation, and on right hand side we have a function of form that is linear. See, this matches with the expression ax plus by. We can easily compare ax plus by with this expression, and we can obtain our a and b. So to solve this question, first we have to focus on complementary function part. Complementary function, what we have to do to solve complementary function, we have to just factorize this equation. We have to first place m in place of d, 1 in place of d dash, obtain this auxiliary equation, factorize this equation, and obtain the roots of this equation by any previously learned method. After obtaining roots, we will place these 2 roots in the formula for complementary function, and thus we can obtain the complementary function part. Okay, after this, now we move on to particular integral part. This is the general method of writing particular integral, 1 upon function of dt dash, and right hand side function is written over here. We are using second general method to solve our question. What we have to do here, we have to place, first I have told you that we will compare this with ax plus by and obtain our a and b. So on comparing this expression with ax plus by, we can easily obtain a as -1 and b as 1. So what we have to do, we will replace d with a and d dash with b in this question, in this particular integral part. If this is non-zero, we can proceed further. We will place integration according to the order of this equation. This equation is of second order, so we have placed 2 integration sign over here. Then what we will do, this 24 is, since it is constant, we can write over here because it is nothing to solve with this part. It is a constant part, and this function we have to write over here. But before placing it over here, we have to place it as u for some time. Now we will solve this part, and we can easily obtain the integration part of this function that has been obtained in the form of this, and solve finally with this part also. So on solving this complete part, we can obtain this. Finally, we have to place u back to this term that was assumed previously, and this is the particular integral part of this question. Final general solution can be written in the form of sum of CF and PI. CF is this part and PI is this part. So this is the complete solution of this question. Let's move on to another example. Let us take one more example to solve this question, solve this method. Let it be 2d square minus dd dash minus 3d dash square into z. Again, one should understand that this is a homogeneous partial differential equation of nth order. Right hand side function is the exponent function with this linear expression. So we will compare this expression with ax plus by and recognize our a and b. Before that, do not forget to solve complementary function part of this question. And when we are going to solve this particular integral part, we will just write, we can compare this part with ax plus by and obtain our a and b. On placing a in place of d and b in place of d dash, in this question what is happening actually, this expression is becoming 0. So this is the form of case of failure actually, because this method fails over here when this part becomes 0 on placing d as a and d dash as b. So we have to use case of failure method. In that method, what we do actually, we place an x over here, differentiate this equation with respect to d, and write the expression, over in the same way. We use the method once again, and in this part now it's not becoming 0 when we write a in place of d and b in place of d dash actually. So we can proceed further with this method. Now this equation is of order 1. So one integration is placed over here only. So we have solved it in the same manner. We have placed a in place of d and b in place of d dash. Then put an integration because this equation is now linear form. E to the power u, we have replaced this expression with u for some time. And finally we will integrate it. Thus, we have obtained this expression. Hence, we can obtain the complete solution by writing it in the form of complementary function plus particular integral. I hope this lecture video was beneficial for you, and thank you so much class. Keep learning.